Alright, welcome back. So the test is today. It is in a few hours. Scheduled at, gotta log in at 9, so 6, 7, 8.5, so 2.5 hours. This video should only take about a half an hour. Mic check, looks good. Noise floor. Noise floor is kind of bad, but anyway, this is the last video. It's just a short review video again. So, yeah, it's just, there's bad weather, so I'm up early, so let's, get this out of the way. So, merge lines of files, write lines consisting of sequentially corresponding lines from each file, separated by tabs to standard output. The answer is paste, P-A-S-T-E. A paravirtualized guest, or PVM, is one where the guest operating system, is aware that it is running a virtual. So guest drivers is the answer. Got it. The command blank is used to modify permissions. That's chmod, C-H-M-O-D. One problem with locate is that it only shows entries present in the database generated by update db, UPDATE db. In the vi normal mode, to discard the swap file when prompted by vi, press capital D. The command to manually blank a file is called mount, M-O-U-N-T, and not a file system. Got it. Blank contains site-specific data, which will be served by the system. That's /srv. Got it. In general, secure shell servers don't have the same type of key infrastructure that web servers depend on. Most secure shell servers rely on blank that are created, and these are SSH host keys. Got it. And I can have sedentary time if I want it. Don't want it right now. Blank is a very useful command that shows the full path to an executable. So the answer to this is where, W-H-E-R-E. That was incorrect. The answer was which is important to know. So if I want to find man pages, where is the correct one. If I want to find the full executable to a path, then which is it? Which is the correct one. Then there's also file, and there's also type. Those are further commands. So what I'm going to do is have a conversation with the AI. Okay, so help me with this. So in Linux, there are a number of commands. One of the commands is where is, another command is which, another command is type, and another command is file. So what would be the name for like this family of commands, these sorts of commands? So these commands are all, from what I understand, meant to do a certain thing, and it's kind of related the thing that they're meaning to do. So like, what is the word for the thing that all of these commands intend to do, and how can I keep each command straight and remember which is which and not get them confused about which one does what?
The commands where, which, type, and file can be categorized as commands used to locate and identify files or commands on a Linux system. Here's a brief description of each. Where. This command is used to locate a command. It returns the path names of the files, or links, which would be executed in the current environment. Which. This command shows the full path of the shell commands. Type. This command displays how a command name is interpreted by the shell. File. This command determines the file type.
There we go.
The commands whereas, which, type, and file can be categorized as commands used to locate and identify files or commands on a Linux system. Here's a brief description of each. Whereas. This command is used to locate the binary, source, and manual page files for a command. Which. This command shows the full path of the shell commands. Type. This command displays how a command name is interpreted by the shell. File. This command determines the file type. To help you keep these commands straight and remember which is which, you might try creating a mnemonic or a rhyme. Alternatively, you could create a mental map or diagram that groups these commands together and highlights the key differences between them. Whereas and which both help locate commands, but whereas shows the locations of the binary, source, and manual page files, while which shows the full path of the shell commands. Type is also about locating commands, but it gives more information about how the command will be interpreted by the shell. File is a bit different because it's about determining file types rather than locating commands. Regarding the command where, it is not a standard command in Linux. However, it is possible that some Linux distributions or shell environments might include a where command as an alias or function that behaves similarly to which or whereas.
All right. All right, so can you help develop my intuition for these commands?
Sure. Here are some guidelines that might help develop your intuition for these commands. Whereas, think of this as where is everything related to this command. It gives you a holistic view of all the important files related to a command, including its binary, source, and man page. This is useful when you want comprehensive information about a command. Which, this is more specific than whereas. Use which when you want to know which executable file will be run when I type this command. It returns the path of the executable file, helping you identify exactly where a command is located in the file system. Type. Use type when you want to know what type of command is this. It will tell you how the shell interprets a command, whether it's an alias, a function, a built-in, or an external command. This is useful for debugging and understanding the behavior of a command. File. Think of this as what type of file is this. It's not specifically for commands. You can use file to determine the type of any file in the file system, not just executables. It's a versatile tool that can help you understand more about a file's content and structure. So, in summary, whereas gives you comprehensive information about a command, which tells you the path of a command, type tells you how a command is interpreted, and file tells you about the type of any file in the file system.
Okay, and then what is the holistic sense of these commands again?
These commands are all tools to help you gain more information about files and commands on your system. The holistic sense is that they're all about discovery and understanding. They help you discover where files and commands are located, which, whereas. They help you understand the nature and type of commands and files, type, file. So, if you're working on a Unix or Linux system and you need to gather information about commands and files, these are some of the tools you'd use. They are about increasing transparency and giving you the ability to look under the hood to understand how things are working and where to find them.
Can you show me an example of some real world work that a system administrator or whoever needs to would do on a system where they would need to use these commands? Could you show me some additional commands that they might use in a holistic way to accomplish the things that these commands are meant to accomplish, and show me some real examples of the command line output and how they would be used by the person that needs them?
Certainly. Let's say a system administrator is troubleshooting an issue with the Nginx web server on a Linux system. Here's how they might use these commands in a holistic way to gather information and troubleshoot the issue. Which to find the path of the Nginx command. This tells the administrator that the Nginx executable is located at /usr/bin/nginx. Whereas to find related files for Nginx. This gives the administrator a comprehensive view of all the important files related to Nginx, including its configuration directory, /etc//nginx, and its man page, /usr/share/man/man8/nginx. 8. GZ. Type to understand how Nginx is interpreted. This confirms that Nginx is an external command and shows its path again. File to determine the type of the Nginx executable. This tells the administrator that Nginx is a 64-bit Linux executable file. In addition to these commands, the system administrator might also use the following commands as part of their troubleshooting process. PS to check if Nginx is running. Netstat to check if Nginx is listening on the correct ports. Tail to view the Nginx error log. These additional commands, combined with the information gathered from which, whereas, type, and file, give the system administrator a comprehensive view of the Nginx web server and its current state. This whole.
Can you give me like a template, a workflow template, or like maybe it's called a cheat sheet? I don't know, but I guess I'd prefer like a MOP, like a method of procedure that like a administrator could use on the job, just have like in their back pocket and like pull up this template or method of procedure so that like they have just an algorithm to go through if they don't know exactly what they need or why. And can you explain each part of this and like the intuitions that it will build and like the necessary why the information is necessary and like what it could be used for?
Certainly. Here's a workflow template or cheat sheet that a system administrator could use as a starting point for troubleshooting issues on a Linux system. Identify the command or service use which to find the path of the command or service. Use type to understand how the command is interpreted. Gather comprehensive information. Use queries to find related files for the command or service. Use file to determine the type of the executable. Check the running state. Use PS to check if the command or service is running. Use systemple or service to check the status of the service, if applicable. Check network and ports. Use netstat to check if the command or service is listening on the correct ports. Check logs and configuration. Use tail or cat to view logs. Use grep to search for errors or specific messages in logs. Use cat or vim to view configuration files. Additional tools and commands. Use top or hop to monitor system performance. Use df and do to check disk space. Explanation and intuition. The first step is to identify the command or service and gather information about how it is interpreted and where it is located in the file system. This is important because it helps you understand the environment and the context in which the command or service operates.
Misconfigured.
The second step is to gather comprehensive information about the command or service.
That makes sense.
This includes finding related files and determining the type of the executable. This information can be useful for troubleshooting issues and understanding the dependencies and configuration of the command or service. The third step is to check the running state of the command or service. This is crucial for identifying issues and determining if the command or service is operating as expected. The fourth step is to check network and ports. This is important for ensuring that the command or service is accessible and communicating correctly. The fifth step is to check logs and configuration files. Logs provide valuable insights into the behavior and performance of the command or service, while configuration files allow you to verify settings and make changes if necessary. The sixth step includes additional tools and commands that can be useful for monitoring system performance and checking disk space. This workflow template or cheat sheet provides a systematic approach for troubleshooting and solving problems on a Linux system. It builds the intuition that troubleshooting is a process of gathering information, identifying issues, and verifying the correct operation of commands and services. It also emphasizes the importance of logs and configuration files in understanding and resolving issues.
Okay, thanks. So this actually makes a lot of sense to me now, because let's say that you're a system administrator hired to like a contract to some random place, and like you show up and just everything's just completely broken and no one there knows what they're doing. Like you could run these commands, which and type, and you could where is and file, and what you could gather from those, sorry, I just gagged literally, but what you could gather from those commands is like if they put the commands like in the total wrong place. Like for example, if there were system-wide configuration files outside of /etc and like in /lib, or like something else that's not following standard conventions, or even the conventions made by the company. Like if things are just all completely unorganized, like the first thing you could do is this reconnaissance information using which, type, where is, and file, and then you can reorganize the systems so that they actually like make more sense and things. So like, can you show me an example of this and like show me this sort of thing, like a real world scenario where you would use this reconnaissance information? Can you show me that, please?
Sure. Let's say you're a system administrator who has just been hired to fix a Linux server at a company. The previous administrator left without any documentation, and no one at the company knows how the system is set up. Your first task is to understand how the web server, in this example, Nginx, is configured and running. Here's how you might use the commands to gather reconnaissance information. Identify the command or service. Use which to find the path of the Nginx command. Use type to understand how Nginx is interpreted. Gather comprehensive information. Use queries to find related files for Nginx. Use file to determine the type of the Nginx executable. From the output of these commands, you learn the following. The Nginx command is located at /usr/local/nginx/bin/nginx, which is not the standard location for Nginx binaries, /usr/bin/nginx. This suggests that Nginx might have been compiled and installed from source, rather than installed from the system's package manager. The configuration files and logs for Nginx are located in /home/user, which is not the standard location, /etc/nginx for configuration files, and /var/log/nginx for logs. This is a red flag because it indicates that the system is not following the standard conventions or the conventions made by the company.
Right.
With this information, you can now start reorganizing the system to make it more manageable and in line with standard conventions. For example, you might choose to move the Nginx configuration files and logs to their standard locations, and update the Nginx service to use the new paths. This will make the system more predictable and easier to manage for anyone who works on it in the future.
Might reorganization be more trouble than it's worth, though, especially if this is a production system? Like if it's some simple issue like the ports are messed up or like the process isn't running, might it be better to just like turn the process on and let people get back to work than do this giant reorganization effort for a system where the organization really isn't all that important in the end? It's just whether or not people can use it for their mundane daily business as usual tasks.
You're absolutely right. In a production environment, the priority is typically to restore service as quickly as possible. In that case, the approach would be: address the immediate issue and restore service. Once service is restored and stable, assess the system's organization and structure. If reorganization is needed, plan and implement those changes during a scheduled maintenance window to minimize disruption. Reorganization can be a significant effort and can introduce risks, especially in a production environment. It's important to weigh the benefits of improved organization against the risks and costs of making those changes. In many cases, documenting the current setup, including any non-standard configurations or locations, may be a sufficient and less risky alternative to reorganization. This way, future administrators can understand and manage the system more effectively.
So are you familiar with the term hot swappable? This is like where you take a piece of hardware and while the system is live and running, you can take the hardware out or you can put it in. So like, for example, a USB drive is hot swappable. Like, in my opinion, I don't know if that's the exact example for this concept, but are you familiar with the concept of hot swappable? So my question is, if you're familiar with this concept, is there something you can do regarding organization of the system that is the same concept of being hot swappable, where you can allow people to keep working while you do the reorganization, perhaps through hard or soft links, and then just there's one point where maybe everything goes down for like a few seconds or things just don't go down at all, and you've reorganized the whole system and just seamlessly shifted things to a new structure without anyone noticing? Is there a way to do that on a Linux system?
Yes, you can apply a similar concept to reorganize the file system while minimizing downtime using symbolic links, also known as symlinks. A symlink is a file that points to another file or directory. It's similar to a shortcut in Windows. Here's an example of how you might use symlinks to reorganize the Linux configuration files and logs. Create the new locations. Create the new directories for the configuration files and logs in their standard locations. Copy the files. Copy the configuration files and logs from their current locations to the new directories. Create symlinks. Create symlinks from the old locations to the new locations. Update Linux configuration. Update the Linux service or configuration to use the new paths. This step might require a brief downtime or reloading of the Linux service. Test and verify. Test the configuration to ensure that Linux is working as expected. By using symlinks, you can keep the old paths valid while moving the files to the new locations. This allows you to reorganize the file system without affecting running services or users. However, updating the service configuration to use the new paths might require a brief downtime or reloading of the service, depending on how the service handles configuration changes. This approach can be used for any files or directories that...
Can you tell me more about step 4, updating the configurations? Can you show me an example of this?
Certainly. In step 4, we update the configuration files or service files to point to the new locations. Here is an example for Linux. Identify the configuration file. Use the Linux command to identify the main configuration file location. In this example, the main configuration file is /usr/local/linux/conf/linux. Conf. Edit the configuration file. Edit the configuration file and update any paths to point to the new locations. For example, if the configuration file contains a line like, update it to point to the new location. Reload the service. After updating the configuration file, reload the Linux service to apply the changes. Alternatively, if your system does not use systampl, you can use the Linux command to reload the service. Verify the changes. Use the Linux command again to verify that the configuration is still okay. These steps will update the Linux service to use the new locations for configuration files, logs, or any other paths that you have changed. The reloading of the service should be quick and should not require significant downtime.
Wait, can you just more simply, in this example, just show me the old location and the new location? I want to understand the new location better. It looks like there's a configuration file, and I was expecting that to be in /etc, and that my intuition about that was incorrect. So, like, why did you choose this new location outside of /etc? Like, what even was the new location that you chose? And help me understand your intuition for choosing this and develop better intuitions about Linux organization.
Sure, let me clarify. In the original example, Linux configuration files were in /home/user/linux. conf and logs were in /home/user/inc/logs. The standard locations for these files on a Linux system are /etc/inks for configuration files and /var/log/inks for logs.
Yeah.
So, in the example, the new locations are new location for configuration files.
But then you need
/etc/inks new location for logs. /var/log/inks the /etc directory is a standard location for system configuration files in Linux.
But the thing is with that, and I can imagine this being the case in like a production environment, is if you put it in those standard locations /etc and /var, don't you need like sudo access to just do like sudo? Don't you need like that kind of administrative access to just do basic things if they are in those file system, those folders? Like I could see the reason somebody put it in the /home/user would be that they didn't want to have to use sudo or like ask somebody permission to just like ask. They didn't want to have to go through an administrator or some complicated process just to do some simple thing that they're meant to do like 100 times a day. Like I could see that being the reason why it's not organized. So like if I were to reorganize it, wouldn't I cause a major disruption to the department by requiring everyone to use sudo administrative escalated privileges? How could I prevent this? Like how could I prevent the reorganization from being a major burden to the department in ways I can't foresee?
You've raised an important point. Moving files to /etc or /var would indeed require users to have administrative access to modify them,
right,
which could be disruptive if they are used to working without sudo permissions.
Just add them to the sudo.
To mitigate this, you can set specific permissions on the directories and files to allow non-root users to read and / or write as necessary. For example, change the ownership of the new directories to the user who needs access. Replace user and group with the appropriate username and group. Set the permissions. Set the permissions to allow the user to read and write files. This will allow the specified user to read and write files in the new locations without requiring sudo access. However, note that this could introduce security risks by allowing non-root users to modify system configuration files, so you should carefully consider the implications and consult with your security team before making these changes.
Not the folders. Do it for the files, not the folders. Okay, so that's a fair answer. Like, thank you. That's actually really a good answer. Basically, it just comes down to like you have to be a competent system administrator and you have to actually know how to use Linux. So like, yeah, you put them in the standard locations, but then the files that people are like actually using, you change the permissions on so that they can use them, and then you make sure these users are in appropriate groups, they are in the correct groups. So like what I'm saying is that the users, they have to be in the correct groups, the appropriate groups. Inappropriate was a typo. What I meant to say was appropriate. So what I am saying is that it's important to be a competent system administrator and to know basic things about Linux, such as permissions and groups, so that you can put your users in the appropriate groups and you can appropriately separate the permissions and the duties that the user have. Like, for example, full-time employees get more access than contractors.
That's exactly right. Being a competent system administrator requires a solid understanding of Linux fundamentals such as permissions, groups, and user management. This knowledge allows you to create a system that is both organized and functional while also meeting the security requirements of your organization. In addition to the points you mentioned, here are some other best practices to consider. Document everything. Document the structure of your system, the groups you've created, and the permissions you've set. This documentation will be invaluable for future administrators and for troubleshooting. Regular audits. Regularly audit your system to ensure that users still have the appropriate level of access and that no unauthorized changes have been made. Use version control. Use version control for your configuration files. This will allow you to easily roll back changes if something goes wrong and track changes over time. Backup regularly. Regularly backup your system, including both data and configuration files.
Tell me more about using version control for your configuration files. That seems like putting them all up in a centralized repository could be kind of a security risk. I don't know, like where would you put them? Up on Bitbucket or GitLab or like whatever internal version control? Like, tell me more about version control for these types of files. Are there any special considerations that they would require?
Using version control for configuration files is a best practice because it provides a history of changes, makes it easy to roll back to a previous version, and simplifies collaboration among team members. However, you are correct that there are security considerations.
Sorry, I have to take a quick break. And I'm not talking to the microphone. I'll have to take a quick break when I come back. We'll read about that and then finish out these cars. This is the last chance I have to review, so I'm kind of being going off on a tangent and trying to learn as much as I can. So I'll be right back. All right, welcome back. So let's finish out these cards. The test is just in hour and a half. So we'll hit the treadmill again. All right, and let's finish out these cards. So now this one I believe I got wrong. So the directory is provided so that the system administrator may temporarily mount a file system as needed. This is /mnt. In order to control the machine, the operating system's main component, the kernel, must be loaded by a program called a bootloader. As a Linux user, you will often copy files from one location to another, whether it is moving a music file from one directory or to another system or to a system file. Use CP for all copy tasks. The UEFI is used by machines. UEFI. Sorry, no, wrong. So this is a partition, and we can see that here. So the EFI system partition, the answer is ESP. Yeah. So I can tell that because it says here that it's a partition and it's formatted in the FAT-based file system. On a disk partitioned with a GUID partition table, it has a globally unique identifier of that. If the disk was formatted under the MBR scheme, the partition ID is EF, and that's important to know. We're talking about the ESP system partition, and it could be on a disk formatted under the MBR partitioning scheme or the GUID partitioning scheme. If it's MBR, then the partition ID is EF in hexadecimal. If it's on the GUID, then it's that whole thing. Starts in C12A. Got it right. Managing software repositories. For Yum, the repos are listed in the directory / now these are repos. Now these are like configuration files of the repos, I'm guessing. So I'm gonna go with /etc /yum.repos repos.d. Yeah, so /etc /yum.repos with an s.d. Good. The command to create a hard link on Linux is ln. Yeah. Is that the same command for numbering lines? Let me ask the AI.
No, ln is used to create hard and symbolic, soft links between files.
It looks
The command
similar.
you're thinking of for numbering lines is nl.
It looks similar. So, container technology, so an application container. Got it. To debug the XFS file system, the utility fxs, so xfs_repair, REPAIR. Wrong. So this is to debug. So the answer is _db. Repair would be to like defragment the drive. Got it wrong. Used to swap out kernel memory pages when RAM is heavily used. This is swap space. You can check this by using the -I parameter of inode, I-N-O-D-E. Or sorry, of ls. The answer is ls. Good. This is the inode information, but you get that by using the ls command. Alright, so this is bunzip2, B-U-N-Z-I-P, the number 2. Wrong. This is, so it's not unzipping, it's zipping, so I got that wrong. So I need to do it again. So blank is used to create, oh, this is a hard one. Okay, so I'm going to go with MKE2FS. Got it. So it's used to create an ex2, ex3, or ex4 file system, usually in a disk partition. Device is the special file corresponding to the device. Blocks-count is the number of blocks on the device. If omitted, MKE2FS automatically configures the file system size. Got it right. The blank command that our previous type command traced for us will return nothing but the absolute location of the file. So we know that there's file, we know that there's type, we know that there's where is, and we know that there's which. This one is file. Wrong. This one is which. Got it wrong. Partitioning the disk is only the first step towards being able to use a disk. After that, you will need to format the partition with file system before using it to store the data. The standard tool to create a file system in Linux is MK2FS. Nope, the standard one is MKFS. Wrong. The blank is an archive containing a file system used as a temporary root file system during the boot process. So, oh, right, okay. So this is init RAM fs, init RAM fs. init RAM fs. So the init RAM fs is an archive containing a file system used as a temporary root file system during the boot process. Yeah, I know this because it's a temporary file system which comes from the RAM. The purpose of an init RAM fs file is to provide the required modules so the kernel can access the real root file system of the operating system. This directory contains everything required for the boot process except configuration files not needed at boot time and the map installer. Thus, blank stores data that is used before the kernel begins executing user mode programs. This may include saved master boot sectors and sector map files. Interesting. Now it's a directory. I'm going to go with /etc/init.d. Nope, it's /boot. Wow, I really got that one wrong. That was kind of my first instinct, but for some reason, I overrode that instinct. My mind was actually wandering quite a bit as well. So, fortunately, I'm doing, this is the last week of October, and there's these things called Prolon Fests that, to get the most benefit, you do it in 3 consecutive months. So if I start it today, I'll have done so, even though I do it at the very last opportunity for the month. So I really can't push it back any further, or else it won't be on 3 consecutive months. So no stimulants for me today. Hopefully that won't make a huge difference. So blank is a similar command, which will show information about a binary, including where it is located and its type. So we've got Okay, so this I'm going to go with type, type. There we go. And we know that where is for man pages. We know that which is for absolute paths, and then we know that type is for type, and we know that files is for more information about the file. So you would not pass a binary to the command file. You would pass a file. So you'd use something like this syntax instead of this. Got it right. So fsck itself will not check the file system. It will merely call the appropriate utility for the file system type to do so. In the example above, since a file system type was not specified, fsck assumed an ex2/3/4 file system by default and called interesting. I'm going to go with mk2fs. So e2fsck is the correct answer. So blank is a very useful command that shows the full path to an executable. So this is an executable. Oh, you know what? I think this is actually which. Yeah, this is which. So which does work on executable. So yeah, okay. All right, got that one right. Cloud-init is not just for virtual machines. Cloud-init, the Cloud-init tool suite can also be used to pre-configure containers such as LXD cloud containers prior to deployment. Linux container is the right one. All right, so perhaps due to a corrupt or malformed configuration file, so you would do the dpkg dash reconfigure utility. dpkg dash reconfigure. During system initialization, the init program identifies the requested run level defined by a kernel parameter or in the blank file. So this is /etc /init-tab. So /etc/init-tab. So during system initialization, the init program identifies the requested run level defined by a kernel parameter or in the in that file, and loads the associated scripts listed there for a given run level. There are other commands that handle compressed files. So there's bzcat. Got it. Specifying the name of the device containing the file system to mount may introduce some problems. The command blank can be used to query information about a file system and find out the label and UUID associated to it. Interesting. I feel like I don't know this one. I'm going to go with FSCK. Oh, no, it's LSBLK. Wow, okay. Good thing I'm getting that one. So grub legacy menu entries and settings are stored in the file /boot. Now these are legacy menu entries. So this is /grub/grub.conf. No, wrong. These are legacy menu entries. Okay, so it's menu.lst. The blank command is one of the most important command line tools you should learn in order to navigate the file system. In its basic form, ls will list file and directory names only. Blank is reserved for the initialization of add-on application software packages. A package to be installed in blank must locate its static files in a separate blank package or blank provider directory tree where package is a name that describes the software package, and provider is the provider's LANANA registered name. This is /OPT. DU works at the files level. There's another command that can show you disk usage. This is how much space is available at the file system level. This command is, I'm going to go with DF. Got it. So DU works at the files level, but there's another lower level command that can show you disk usage and how much. So this DU shows it for a file system, but DF shows it for the whole disk. So like that includes like partitions. So it shows how much space is available at the file system level. Oh, sorry, no. So DF doesn't work at the file system level. It works. So let's go to the AI. And we're going to ask it, what is the difference between a command working at the files level and working at the file system level? I'll do a new chat for this one.
A command that works at the file level interacts directly with individual files or directories, examining their properties, content, or structure. The do disk usage command is an example of a file level command, as it calculates and displays the disk space used by individual files and directories. On the other hand, a command that works at the file system level interacts with the entire file system structure. It is concerned with the organization and management of data on a disk or partition as a whole, rather than with individual files or directories. The DF disk-free command is an example of a file system level command, as it provides information about the total space, used space, and available space on the various mounted file systems on a system. In summary, the key difference between the two types of commands is the level at which they operate. File level commands interact with individual files or directories, while file system level commands interact with the overall structure and organization of data on a disk or partition.
Okay, so tell me more about partitions. Like this, partitions are relevant to this in some way, right? So like, how does these commands work with partitions?
Yes, partitions are relevant to this discussion because a partition is a logically segmented section of a hard drive. When you format a partition, you create a file system on it, which is a way of organizing data on the disk. Each partition with a file system can be mounted to a specific directory in the system, making its data accessible. The df command displays information about all mounted file systems on your system, and since each file system is associated with a partition, it indirectly provides information about the disk space usage of each partition. Here's how the commands work in relation to partitions. df. The df command provides a summary of disk space usage for each mounted file system, which corresponds to a partition on your disk. It displays the total size of the file system, the amount of disk space used, the amount of disk space available, and the percentage of disk space used. Do. The do command can be used to analyze the disk space used by files and directories within a specific partition. While it doesn't interact directly with partitions, the output will depend on which partition the specified files or directories are located on. In summary, df provides an overview of disk space usage at the partition level, through its view of file systems, while do allows you to analyze disk space usage at the file or directory level within a specific partition.
Okay, satisfied with that. I got this one right, so let's move on. To debug, so this is to debug, so the answer is xfs_db. Alright, so this is compression, so it's bzip2, bzip, the number 2. Alright, so the blank command that our previous type command traced for us will return nothing but the absolute location. So we've got multiple commands that could be relates to this. We've got where is, we've got which, we've got file, and we've got type. So we're talking about a command here. So I'm going to go with type. Oh, sorry. It's not type. Oh, let me go with file. Okay, so it is which. Man. So I'm going to go to the AI. Help me get this right. I keep getting it wrong. I answered file this time.
The command you are referring to is which. The which command is used to locate a command's binary in the system's path. When you run which followed by a command name, it returns the absolute path of the command's binary, showing you where the command is installed on your system. For example, in this example, which ls returns /bin/ls, indicating that the ls command is located in the /bin directory.
Okay, well, I keep getting it twisted with other kinds of commands, such as WHEREIS, such as FILE, such as WHICH, such as TYPE, such as FILE. So, like, help me keep these commands straight, like create mnemonics and tell me intuitive ways that I can remember which is which.
I understand that it can be confusing to remember the difference between these commands since they all provide information about files and commands on your system. Here are some mnemonics and intuitive ways to help you remember which is which. Which mnemonic? Which way to the command? Intuition. Use which when you want to know the exact path of a command. It tells you which way to find the command in your system's path. Where is mnemonic? Where is the command and its man pages? Intuition. Use where is when you want to find the binary, source, and man pages for a command. It tells you where in the system you can find all related files for the command. Type mnemonic. What type of command is it? Intuition. Use type when you want to know the type of a command, whether it is a built-in, alias, or external command, and its path if it is external. It tells you the type of command you are dealing with. File mnemonic. What type of file is it? Intuition. Use file when you want to know the type of a file, whether it is a text file, executable, etc. It tells you the file type without giving the path or other information about the file. I hope these mnemonics and intuitive explanations help you remember the differences between these commands.
So I don't know, it seems like for type it could make sense because it like that one makes sense, and then file could make sense because that's for a file, but for where is and for which, those seems like WHEREIS, like that command, and then for WHEREIS, you know what I'm talking about, that command where is, like the WHEREIS command. It seems like that command and the command which are really easy to mix up. So like I wish there was the letter M in the command WHEREIS, because then I could associate it more easily with man pages. Is there anything you can think of where like the letters in each command can give me a clue as to like which one is referring to the path and which one is referring to the binary source and man pages? Can you even give me like a better understanding, please, of a system's path? Like, what is the difference even between finding a path and finding binary source and man pages?
Sure, I'll do my best to help clarify. Path. The path of a command is the location in the file system where the command's executable file is stored.
Okay.
It's like the address of the command on your computer. Binary. A binary file is an executable file that contains compiled code that the computer can run. When you type a command, the system runs the binary file associated with that command. Source. The source refers to the original source code files from which the binary was compiled. Source files are not always available on your system unless you have installed them separately. Man pages. Man pages are manual pages that provide documentation on a command, including what it does, how to use it, and what options are available. Now, regarding where is and which gives you the path of a command's binary. This is like asking which directory do I find the command in. Where is gives you the binary, source, and man pages for a command. This is like asking where is the command, its source code, and its manual.
Okay, I think I have a good mnemonic actually. So here's my mnemonic. So like for the command which, WHICH, it has the letters C and it has the letters H. So my understanding of the difference between a path and the difference between like the actual binary is the path would be like the address of a home, like the numbers on the home, and then on the map, like you would see the address and you would see like the picture of the home. But then the binary would be the actual home itself that you would like go inside and live in or like work on or whatever once you have the address. So like one way I could remember it is for which, WHICH. It has the letters CH, which I could interpret to mean see home. Like the letter C could stand for SEE, and the letter H could stand for home. So it could be like see home, like you're seeing the home from the street and you're looking for the address. Whereas where is, WHEREIS, that last two letters I and S could be like, is, like it actually exists. It's the actual real home. It's not just the address. I think this will help me remember it.
That's a fantastic mnemonic. I love how you've utilized the letters in each command to create a visual and memorable association between the command and its function. Which equals see home, CH, helping you remember that, which shows you the path or address of the command, just like you would see a home's address from the street.
Right.
Whereas equals is, IS, helping you remember that whereas provides information about the command's existence, including its binary or actual home, source, and man pages. This is a great way to differentiate between the two commands and remember which one provides the path and which one provides more comprehensive information about the command. Well done.
Okay, I've got it figured out now. So this one I got wrong. All right, so the standard tool to create a file system on Linux is, I just don't know. Oh, MKFS. That was my first instinct, actually. So the directory contains everything required for the boot process except configuration files not needed at boot time and the map installer. Thus, blank. So this is /boot. /boot stores data that is used before the kernel begins executing user mode programs. This may include saved master boot sectors and sector map files. So cloud-init is not just for virtual machines. So this is Linux containers. Yep. FSCK itself will not check the file system. It will merely call the appropriate utility for the file system type to do so. In the example above, since a file system was not specified, FSCK assumed an E234 file system by default called MKE2FS. Wrong. The answer is, now remember, this isn't for making a file system, this is for checking one. So it should have CK in it. So this is the right answer. I got it wrong. Grub legacy menu entries. So this is menu.lst. Alright, so the command blank can be used to query information about a file system and find out the label and UUID associated with it. Huh. I don't know. LSBLK. Shoot. On Linux, the system can... Oh, this is proper. The partition needs to be set up with a proper utility, mkswap. Got it. Kill processes by name. There could be more than one. So this is kill all. To search for files on a Linux system, you can use the find command, FIND. The configuration file /boot/grub, which is used to create a list of operating systems to use in the menu's interface, essentially allows user to select a preset group of commands to execute. So I'm going to go with grub.cfg. And okay, good. So this is grub.conf. So now I can see, this is why this is so valuable, because it'll narrow those down. So like the more you do this, like at the end, if you keep getting these mixed up, it'll keep asking you them. So you can see I keep getting these two mixed up, and then you'll see it time and time again that you're getting it mixed up, and you can sort it out. So I got this one wrong. All right, so now let's look at the permissions. They come from user mask or umask, UMASK. So what it does is it subtracts from the default permissions. The default permissions are usually 777 for folders, and then I believe 666 for files. So on a Linux system, there's a command called umask, UMASK, and what I understand this command does is it subtracts from the default permissions in a Linux system and those default permissions are usually 777 for folders and 666 for files. Is this correct? So, like, for example, if a UMASK setting were set to 022, then the 0, the number 2, the number 2, then the default permissions would now be 755 for folders and 644 for files. Is this correct?
Yes, you are correct in your understanding of a mask, but there is a small clarification needed. The OMask, user file creation mode mask, is used to determine the default permissions for new files and directories. However, the default permissions are not always 777 for directories and 666 for files. It depends on the system and the specific circumstances under which the files and directories are created. When a new file or directory is created, the system starts with the default set of permissions and then subtracts the OMask value to determine the actual permissions. The default permissions for directories are usually 777, and for files they are usually 666.
That seems really twisted because, like, imagine a test asking you, like, what would the default permissions be, like, if UMask was set to 022, like UMASK, like the command that we are talking about, UMASK, like that command. You know the command I'm talking about, right? The one we're talking about. Like, what if you were taking a test and it were to ask you what the permissions of a file would be if the settings of UMASK, the command that is relevant to this conversation, like if that was set to 022, you had to 0 the number 2 the number 2. Like if the UMask setting, UMASK, the thing we're talking about, like if that setting was set to the number 0, then the number 2, then the number 2, and there was a multiple choice question, and they asked you, with this setting of this command we're talking about, UMASK, what would the permissions be? Well, you could be like, you know, it would be 755 for, you know, if it was a folder. So, but the thing is, you wouldn't necessarily get that right because it depends on the system, and they're not telling you what any more information that you need. Like, you need to know what the default permissions are. So this is kind of an unfair question, right? Because they're not giving you all the information you need to answer it correctly.
You're absolutely right. In order to correctly determine the default permissions after applying the OMask value, you need to know the default permissions before the OMask is applied. While 777 for directories and 666 for files are common default permissions, this is not always the case. The actual default permissions depend on the system and the specific circumstances under which the file or directory is created.
Exactly.
If you're taking a test or facing a situation where you need to calculate default permissions after applying OMask, you should clarify or be given the default permissions before OMask is applied. Without this information, you won't be able to accurately determine the resulting permissions.
Do you think, though, it's probably safe to assume it's 777 and 666, though? Like, is it worth raising a fuss over, or should I just answer it making those assumptions? Because it seems like a pretty trivial, easy question that really it's just testing you on what happens when you actually set a UMASK, like, you know, the command we're talking about right now, the command that's relevant to this conversation. Like, when they ask you about that in a question, it's probably safe to assume the default permissions, right? Like, they're not going to try to trick you or leave out information or do something that's not, like, very common. Is that correct to assume that you should just answer this question quickly and move on so you have more time for other questions and not make a big fuss over something that's probably safe to assume a certain way?
Yes, in a testing or academic context, it is generally safe to assume that the default permissions are 777 for directories and 666 for files unless specified otherwise. These default values are commonly used in educational materials and examples to simplify the explanation of how OMask works.
Okay.
If the question does not provide specific default permissions, you can make these assumptions and proceed with calculating the resulting permissions after applying the OMask value. However, it would be good practice to state your assumptions in your answer, such as assuming the default permissions are 777 for directories and 666 for files. The resulting permissions would be. This way, you are covering your...
Okay, well, that's good. So, yeah, this is UMASK. All right, another directory directly related to files in a standard Linux system is blank. So this is /dev, and it's directly related to devices. /dev contains files associated with a system device, particularly storage devices. So the command blank is used to modify the ownership. This is chown, CHOWN. Got it. In the vi normal mode, to enter insert mode at the beginning of the current line. So this is capital I. Inside the blank.d directory, you can add files with additional repositories to be used by apt. So the answer is /etc/apt /sources.d. Nope, sources.list.d. Update-grub is usually a shortcut to grub-config. Nope, grub-mk config. Blank command is used to blank a file. So this is sort. Partitioning the disk is only the first step towards being able to use a disk. The standard tool to create a file system in Linux is mkfs. So in the example above, since a file system type was not specified, fsck assumed that, so it called e2fsck. Yeah. The blank command that our previous type command traced for us will return nothing but the absolute location of a command. So we were talking about a command here, and so we know that where is like the is, you know, it's the actual command. Like but I'm gonna go with so which. Yeah, so which. Yeah, and the reason is because it's the location of the command. So it's like the address of the command in the file system. Where is like the, this is the where is different because it's not about the command, it's about the binaries, the man pages, the things that actually constitute the command, the is. So I think I have this down pretty well now. Which is good, it's just in time. So the command blank can be used to query information about file system and find out the label and UUID associated with it. This is lsblk. Got it. The configuration file /boot/grub/grub.conf. Got it. So it's used to create the list of operating systems in boot. To boot in grub's menu interface essentially allows the user to select a preset group of commands to execute. So inside the blank.d directory, you can add files with additional repositories to be used by apt. So the answer is /etc/apt /sources.list. Right. Update-grub is usually a shortcut to grub-mk config. Got it. All right, and that's it. So really nothing to do now except actually take the test. So I've got 45 minutes here to do with what I will. Probably clean off my desktop and get through those initial checks seamlessly, and definitely get off my treadmill. So yeah, wish good luck to me, I guess. This will be posted soon, and then I will be posting my results. So thanks for watching, and I'll hopefully see you after I've passed this, and then I will work on exam 102.